Okay, so here's our GPS module, and this is a PMB-648 SiRF, and high performance GPS. And we're going to see if we can integrate it with the Arduino to tell where we are on Earth. Okay, that should be an interesting project. Okay, so here is our GPS unit, and we have it hooked up to our Arduino. And I'll just briefly talk about how this thing works. This is actually a receiver. It receives messages from satellites. So we have the Earth here. Let's zoom in on this a little bit. And so okay, so let's say we have Earth, and you're someplace on the Earth. There's a bunch of satellites going around the Earth, right? And these satellites beam radio waves down to Earth, and they're at different positions around the Earth. Okay. And so, let's take a look over here. Let's say you're someplace, and you don't know where you are. So, there's a satellite here, and it sends out a signal. And that signal travels at the speed of light, and you receive it at a certain time. And so you can tell, satellite says, I'm here, and you know when you receive the signal, and I sent the signal at a certain time, T. And so you're someplace, and you know that you're this far from this satellite. So you don't know where you are, you're just on some kind of spherical shell that far from the satellite. So one satellite is not enough to tell you where you are. So let's say you have a second satellite, and it sends out a second signal, and you receive that, and that second signal will intersect the first one, right? That's time one. And this one also sends out a signal, and it tells you you're this far from this satellite, and you're from this position, P2. Right, so you have P1 and P2. So now in 2 space it looks like there's only 2 points. So it's only ambiguous between 2 points, but in 3 space it's actually a circle here. Okay, so you need a third satellite to tell you where you are in that circle. So we have another satellite here, and it sends out a signal, and it intersects this circle. I'll do it so it's easy to see on the paper. Let's say it intersects here. So you see all 3 satellites are intersecting at a point, but actually it's going to be a point on that circle. So you actually need a 4th satellite to tell you height, or a third to remove this ambiguity, because there's actually 2 points that are ambiguous. So the number of satellites you need is 4. That's the minimum you need to determine where you are in space, by using just the distance. So the satellites send out some kind of they have an atomic clock on them, so they're timed very accurately, and they send out some kind of pseudo-random code that comes out in a certain time. And this GPS, and so this GPS guy here is a receiver and a decoder, so it receives messages from all those satellites, and figures out what time. It has a clock in it, so it figures out what time that the message has arrived, and so how far away each of them are, and then it calculates based on that where you are, and it has serial connections that it can talk to the Arduino with. So let's look at how the Arduino is hooked up. Okay, so look at the Arduino. We're just using 3 of the wires here, and so The red one's hooked up to plus 5 volts, the black one is hooked up to ground, and then our Arduino sketch requires that the yellow one here be hooked up to pin 6 for it to work properly. And so let's take a closer look at that. So we have the red one hooked up to 5 volts, the black one hooked up to ground, and then the yellow one is hooked up to pin 6 over here on the other side. And we're going to do serial communication through the yellow line. Okay, there's the antenna and the GPS, or the Arduino, and we'll see if we can pick up these satellites here and determine what position that we're at using just the basic sketch. We'll just want to test this guy out. So we'll get our sketch loaded up, and then we will hook up our USB cable here to our Arduino so we can talk to it through the computer. I'll turn our GPS on and see that it's working because the light's blinking on it. Okay, let's take a look at the sketch. Okay, so here is a simple sketch that we have copied actually from the Arduino page just to test our GPS to see if it's working. And we'll start at the beginning. The first ones include, so Arduino has a bunch of software libraries that they've made, or other people have made also, to make your life easier in programming the PIC processors. And this one is serial communication, and you can do serial communication at TTL level, 0 to 5 volts, through the pins. And so we're going to set up the serial communication with this command here, and we're going to set it up onto pin 6. And so Arduino PICs programs always have two parts. They have a void setup, which sets up the stuff initially, and then they have a void loop, which loops forever. And so here we're setting up serial communication so that we can talk to from the USB cable to the computer, so we can see what the GPS is receiving. And we'll also set up communications to this GPS guy down here. This let's take a look at that. So our little GPS setup that we got going here, and so we need to talk to him as well. Okay. And so after we got all that up, it's gonna just print something to us, and saying, okay, we're reading the GPS, and then it will loop through and it'll just keep on reading all the stuff that the GPS is sending out. It's receiving from the satellites, and tell you what that is. So we'll check the sketch, make sure it's good, and upload the sketch. Okay. Oh. Remember, we always want to make sure our port's set. I'm running Linux, so this is what the port looks like here, but it would be some kind of COM port if you're running on Windows. And so we'll upload the sketch, and the sketch took OK. And so now we have to go into Tools, and we'll start the serial monitor. And okay, so it looks like our GPS is up and running already, and it's spewing out all sorts of garbage here. And I believe that someone on the internet, let's see if we can just stop it for a second. Let's just go up so it stops. We need to stop auto scroll, and we'll take a look at this. Now this is different formats, I believe. It's a compilation of the data from the satellites, and someone recommended using GPGGA, I believe. And so it tells you a certain location north and a certain location east, which are both 0, 0. No, wait. Yeah, it doesn't seem like it's really got our position, maybe. Okay, let's turn auto scroll back on. Could be because we're in the basement, and it's not getting a good signal down here. Maybe it's not able to receive the satellites because we're underground here. So we may have to take it outside. Or maybe, I think it takes a little while for the GPS to acquire satellites as well, because it's got to kind of get everything set up. It's got to talk to them, and it takes a little while for it to figure out where it is on the world. And so here is the normal stuff that comes out of it. Let's stop the auto scroll for a second. Okay. So this first thing is the time. That's what time it is. This second thing here is position north. The other one is position east. And then it has an altitude in here, and it tells you some other things as well. But it looks like they're all 0, 0. So I may have to take this thing outside, and I'm not sure what all this other information is, but the satellites are constantly sending stuff. So this time is ticking up, but I'm not seeing any locations here. So what we may do is we may hook it up to a portable computer and take it outside and see if it can acquire a location and tell us where we are. It should be an interesting thing to do. We want to remember, if you're a good engineer, you always want to test things out in individual parts before you put it into the big picture. Saves you lots of time and money. Remember, I worked one place where we were building cameras for airplanes, special cameras, and the people who were running the program had a great idea of saving a bunch of money. They're making their own cards, they're putting the cards in boxes, and then they put the boxes in the system, and they wouldn't test the whole thing until the whole thing was together. And it took about 20 minutes for the system to load up, and those things are so behind schedule you can't believe it, because you need to test everything first before you stick it together. You save lots of money and lots of time by doing that. It's a very bad idea not to test things. So we're going to go outside, I think, and try to test the GPS and see if it can acquire a position, because it still looks like, let's turn auto scroll off, I'm still not seeing any values unless we're at Greenwich, which I believe is what it's measured from, and I don't think we're in Greenwich, so we're not 0, 0, 0, 0 north and east. But it's receiving the time, it's receiving all sorts of other stuff. Very interesting. Okay, anyway, so shall we? Okay, so I actually let this thing sit here for a very long time, and now it looks like it is reading coordinates now. 3847 north, 07715 west. And so it looks like it just took a while for the GPS to get up and running. So we are reading real coordinates, and so we could use this information to track something if we wanted, or have our robot navigate to some point. Although the error, I believe, we'll have to check it out, is about 15 meters. So the robot would have to travel pretty far to see if it's heading in the right direction or not. But this looks like it could be a very interesting project. So anyway. Okay, we have our mobile unit set up here, where we have our serial port running on the laptop computer out in the open here, and have our GPS over here hooked up to our Arduino, and I copied the starting place where we're starting here, north 3227, or west, what is that? Yeah, north 06772 west. And I stopped the auto scroll for a second, so we'll turn the auto scroll back on. And let's try walking around with the laptop. See if our location changes. Okay. I'll walk over here. Okay. And let's copy, stop the auto scroll, and we'll copy the present position to compare. Present position's down there. And okay, we still didn't go far enough. Looks like the numbers are basically identical. So I guess we need to travel a little bit farther. Okay, so it looks like we walked about 30 feet now, and it looks like we have walked far enough that we see a difference in the numbers. Let's copy the numbers down here. And so we've moved from about 38473227 to last four digits of 3436. Okay. 3436. And 6692. Okay. So I guess we do see a little bit of a change. 38346. Okay. So it looks like our portable GPS thing. We do have to move quite a ways though before we see a difference here. Okay, anyway, this is looks like our GPS is working, and this is Dr. Janes, and thanks for watching.